I'm Tom Bernice, and I have the pleasure to introduce Dr. Michael Workman, who leads the global engineering and development of Oracle's all-flash storage arrays called the FS series. Prior to Oracle, Mike was the founder of and CEO of Pillar Data Systems, an enterprise storage company which was acquired by Oracle in July 2011. He's also been Vice President of Worldwide Development for IBM Storage Technology and a Senior Vice President CTO of Connor Peripherals. Mike's teams over the years have produced over 60 products ranging from disk drives to NAS to SAN storage systems and now all-flash arrays, generating over $17 billion in sales worldwide. He's also a vintner and one of the most interesting people I know. Please welcome Michael Workman.
Thank you very much, Tom. It's a pleasure to be here. I thought that the driving technology, assisted driving technology, is fascinating. I never thought that they'd automate the job my wife usually takes sitting in the passenger seat of the car. But all kidding aside, I have to say that I did my thesis at Stanford in proximate time-optimal digital control. And so when I see those block diagrams up there, which I would never have ventured to show, it's nostalgic. I love it. So I'm a little jealous that we're not working on things like that. But we are working on some very exciting things at Oracle, and I'd like to share some of those with you today. The talk is entitled Flash, Fireworks, and the Cloud. And hopefully, by the end of my presentation, you have a clue as to what those three things have to do with each other. It's the wrong one. So I don't need to tell all of you this because you're here. But the attributes of Flash that we all love are compelling enough in and of themselves. They don't require hyperbole. Just like flash powder in pyrotechnics, which everybody uses, and it is a simple mixture of potassium perchlorate and aluminum dust, much simpler than what many of you are endeavor on making every day, the flash technologies we employ at Oracle in our storage arrays. It is powerful, and it is dramatic, and it requires no hyperbole to explain and no flights of fancy in order to tempt people or compel people to use it. It's spectacular stuff. 6 years ago, I have to remember the ones that I predicted properly, because it doesn't know, prediction is an art, not a science, as you all know. I wrote this, and it essentially was a little bit of a look at what we were all in the industry doing to incorporate flash in our storage arrays. Fundamentally, we took SSDs in the form factor of hard disk drives and we plopped them into the garage provided by storage enclosures that were heretofore for HDD. And it worked, but to be honest, it really was a lame attempt at expressing the value, the latencies, the IOPS, and the true dollars per IOP that flash is capable of. Nonetheless, we were on our way. There were others at the time doing other things like using it as cache, but it was clear at the time, and this is what I was writing in my blog, that the architectures of yesteryear were not adequate. HDD-based or constructed storage arrays were not going to cut the mustard to express and provide or exploit flash benefits to end users, customers. where are we at today? Things have changed from back then, obviously, rather rapidly. And one of the things that has happened is network connectivity as power, compute power has just dramatically advanced. We all know this. It sounds a little trite to say it, but it's just hard for me to imagine. And I look out at the audience and I can see some of you probably weren't in the industry then. But in 1995, it was a big thing to send around an audio clip, not a song, but just a clip. And today we stream video into everybody's living room or laptop, and it's just it's a stunning advance. These connectivity power, compute power have sped up the whole IT infrastructure to the point where we can deliver cloud services to customers. Bandwidth is one of the critical aspects of that. If you look at it, since 1995, it's 3 orders of magnitude of improvement in network connectivity speed. It's amazing to me. But not to be outdone, Moore's Law has continued, and we've seen a 100x improvement in the last 10 years on compute power. Those 2 things alone are rather stunning. They have enabled the cloud. They have essentially changed the geomap of what we see as where we can put function. Nobody in the world would have dreamed about streaming. Well, luckily, some people did dream it. But most of us wouldn't have imagined streaming video into everybody's living room. It just wasn't going to happen when you looked at it 10 years ago. But today, with that kind of connectivity, we no longer have to co-locate compute and storage with users, and that's essentially all the cloud is, at least in our way of thinking. It still has all the same technology in it. It's just where it's located in proximity to the consumer or user of that service. So if you couple that with security, you take the performance, the bandwidth, and compute power, we have really enabled the cloud. We have built a cloud service structure around the world, and you can see that transforming businesses. And it's changed everything for all of us. And it's changed the storage array business. Let's talk about that for a moment. The storage array business was built on HDDs. Since RAMAC in 1956, we had disk drives, and they were sort of our random access model, and tape drive eventually became the archive or the backup or the restore kind of data source. But hard disk drives were our random access model. The good news is that the linear density of disk drives has been an exponential progression. So has the track density. But the bad news is latency hasn't. We all know this. The track density, the distance that you move between tracks is so small that it has absolutely nothing to do with the time that it takes to move the heads in a disk drive. Instead, it's mitigated by mechanical bandwidth or governed by mechanical bandwidth and rotational speed. And those have been a linear progression over the last 50 years. And it's really been in the context of compute power, network bandwidth, and areal density growth, or megabits or gigabits per square inch on a platter. In that context, the access performance has been pathetic. It's a different set of physical problems. It's the problem when you have moving parts. The ugly part of this is that techniques that are being used to extend the areal density curve in disk drives are going to have a deleterious effect on the performance. In other words, I think it's fair to say, if you look at background processes and all the things that disk drive vendors are introducing into the product to deal with the technologies that are being used to advance the state of the art, they're actually going to cause a regression in the performance. Things like shingled magnetic recording and others are actually going to cause the performance to start sliding backwards. And that's a change, a significant one. Additionally, if that weren't enough, we have the problem that the compound annual growth rate of areal density is slowing. I was fortunate enough in my time of 5 years at IBM managing worldwide disk development to be in a period of time where we were doubling it every year. And that was a lot of fun. But that's not the case, and it hasn't been the case recently or for the last several years, and it's slowing down. The technologies are getting harder, they're getting more cost effective, and they're being intrusive on the performance of the drive. All of that is leading to a reduction in the rate of decline of dollars per gigabyte of a disk drive. You can see an inflection point there somewhere around the time of the flooding, but that most people do not predict that that's ever going to return back to the historical trend. And that puts further pressure on HDDs. If we try to sum up some of the attribute differences, if you take a look at latency, fundamentally that's the killer. We all know that. Random access latency to flash is stupendous. It's awesome. It's the thing that we lust after in the storage array business, and many others in many other applications of flash, they love that as well. The sequential bandwidth, this might cause a few people in here to come unscrewed out of their chair. I'm going to make this assertion, and I'll try to back it up, that the sequential data rate is a wash. And the reason is because from my business and my perspective, not in a server-side application of flash, but from my perspective in a storage array, the sequential data rate of an SSD does not really get a chance to express itself. Neither it does for an HDD. I'm going to make this assertion too, which will cause some people to get a little upset perhaps, but I say there's no power difference, or at least not a compelling one, that people shouldn't run around the planet trying to move to flash because of this power difference. It's an advantage, sure. Is it nice? Yes. But it is not the compelling thing that causes a seed change or an inflection point. The reason is because most people, when they do these outrageous comparisons, again, the hyperbole that I opened up with, the outrageous comparisons of flash versus disk are done at idle. The idle power of flash is excellent. The idle power of a disk is it's still spinning, and that's not good. But that in a cloud application of today and tomorrow is not what we want these storage elements to be. We need them to be busy. This is how we drive the cost down of delivering hardware storage services, compute and storage and network. They're not cheap in the cloud. You can't deliver a cost-effective cloud solution if these things are expensive. So therefore, they need to be busy, and therefore I say let's compare them when they're busy. The difference is not that compelling. On the other hand, we have cost. And today I make the assertion, and some of you may say, well, sure. Others say it's that flash and disk are the same price, and I find that to be ridiculous, and we'll talk about that. On latency, it's worthy of note because I know some of the people in here, I recognize them, and I know that they spent a large part of their career trying to break the back of the latency problem with disk drives, especially in storage arrays. We've done a lot of things, cache, all kinds of speed-up mechanisms that we can do to try to hide the effect of latency, read-aheads, and smart caching algorithms, things that we try to do to hide that latency of the disk drive from the end user of the storage machine. Unfortunately, we're kind of out of speed-up technologies. We're at the end of the road. And at the end of the day, when you go get a 4K or an 8K record, it comes down. You can't split that up into 9 devices, and it wouldn't do you any good if you did. You have the latency of the device. Furthermore, let's talk about the sequential now. I want to back up my statement that it's a wash, because I know some of you are saying that SSDs are faster, and they are, because you can put more die and you can planes, and you can parallel those channels and deliver a gigabyte per second out of an SSD or more, and you can't do that out of an HDD. And if you're an NVMe, you can even do bigger than that, which is terrific. My point is that whether you're in an SSD form factor or in a NVMe form factor, in the case of HDD, it could be in a SAS or SSD, those technologies are the limit really quickly with a very small number of devices as to the sequential bandwidth that the customer sees. So the fact that, not in a server side, but again, in the storage array side, the fact that they're twice as fast, an SSD versus an HDD, it's immaterial to me because I can't move the data through the pipes that are provided. Obviously, that points to work we have to do, but that's the reality today. If you think about it, all that says is that there's a balance between memory bandwidth, PCI lanes, and SSDs. If you try to put 200 SSDs behind any compute engine with whatever bandwidth that you could go out and find today, you've swamped that, and it's silly. So you have to go to a scale-out architecture, and indeed that's what most of, especially the startups, for example, have done, and many of the big players, of course, have bought some of the startups, and that is the prevalent architecture, and this is why. Cost. The cost differential is real, okay? And it doesn't really matter who's looking at it. We use this chart sometimes at Oracle. They say that HDD is 30 times cheaper, at least, and SSD is 75 times cheaper in dollars per IOP. Those are material significant differences, and that's why everyone labors to do tiering. You can take off the net, it's not a secret. EMC used this chart. I don't know what they're using today, but the difference that they saw back in 2013 is a prognosis of a 40x difference between flash and capacity disk and an 8x in performance. It's worthy of note, 40x in capacity HDD, some people call it nearline, and only 8x in performance HDD. I want to take a little bit of an aside because this was part of my career while at IBM, and I found it interesting, and I think it will illuminate something that will happen in the future, and that is that eventually the cost won't matter. It won't. As hard as we all work on it, it won't matter. If I told you all you could buy salt for half the price that you can buy it today in the grocery store, would it change your salt consumption? If I told you you could buy salt for 10 cents on the dollar, would you fill your garage with salt? You don't care. And eventually, when even if you were fortunate enough in the HDD world to maintain the multiplier, or the percentage difference between the cost of flash and HDD, the absolute difference will become de minimis, and at that point, the other attributes of flash will be far worth it. In my drone, which is shown here, if somebody told me that I could save half the cost per gigabyte by flying around an HDD in that drone, that's preposterous. I wouldn't take them up on it. And in my career, my team developed the IBM microdrive, and we had a compact flash form factor, CF2, for that drive, and we put it in Canon and Nikon cameras, and it was cheaper per gigabyte, but guess what? In the end of the day, would you rather have a nano SSD in there, or nano flash form factor, or would you rather have a CF2? The answer is obvious. Nobody uses disk drives and cameras anymore. So at the end of the day, as you drive these costs down, pretty soon the differential is de minimis. It doesn't matter. And the other factors like fragility, form factor, pressure, temperature, power, all of those sorts of things take over. This point is to address the hyperbole. You can say anything you want in marketing. You can take out any billboard and make any assertion you want to, but at the end of the day, people make decisions based on tangible metrics that are reproducible and on financial considerations. They're not done on hyperbole. Let's talk about form factor for just a minute, because I find that this is just kind of an interesting observation, that HDDs are the way they are because the platters are round. IBM Research tried square platters, but they made a lot of noise and dissipated 200 times the power. So it turns out that that's why you have that form factor, right? And SSDs ape that because they're borrowing off the worldwide infrastructure to build garages to house them in. And that's all fine. It's very expedient. But I would argue that it's not optimal. And one of the things that I think we need to do is fix this. Now, there's multiple people in the industry that are breaking this form factor. Certainly, we have NVMe doing that, but NVMe doesn't have the RAS characteristics of an SSD or an HDD, the way it's housed, packaged, and interfaced, hot pluggability, et cetera, et cetera. So I find that attractive for the server guys. I don't find it quite as attractive for storage arrays. On the other hand, the Oracle Exadata does use that form factor in its all-flash X5 generation. So not that it doesn't work or not that it's bad. I just think that as engineers, and some of you in here may be working on it, we could do better than these form factors. The SanDisk one is shown there, which is a different package SAS altogether. But nonetheless, people realize that there's a better physical form factor for volumetric density and cooling for flash than we borrow from the HDD world. System. Fundamentally, in the storage array business, there's only really two ways of using flash. There's ancillary things that we do with it, and I'll show you one of those. But there's only really two ways. You either use it as capacity or you use it as cache. And at the beginning, like 2008 timeframe, NetApp, Sun used flash very effectively as cache. It was a very, nothing's easy in this business, as you all know, but it was an easier way than re-architecting your whole system by use it as cache and inserting it into the architecture. There's a problem with flash, and that is you have to ultimately destage it if your end resting place for the data is HDD. My mother used to say it kind of this way. You might have a steak on your plate, at least in the table in my house. You might have a steak on your plate, you might even get a baked potato, but sooner or later, you have to eat your peas. That means if you have a flash cache architecture, you're going to have to destage that cache ultimately to its resting place, which in the case of HDD is not good, or not as good as pure flash solution. Where is all of this stuff going? To me, this kind of matches, I think, pretty well with what you see out of Gartner and IDC and others that track the industry and make prognosis. I think that the internet protocol to storage arrays is going to grow, and really that comes from one simple thing. It's iSCSI, 10 gigabit, and the adoption to use that compute node and storage for the cloud. It's a single network inside of a cloud infrastructure, and people like internet protocol for that. Fiber channel's not going away. It'll stay strong. It'll probably grow a bit. InfiniBand is growing, although it will always be small relative to the others. InfiniBand does grow. I'm not saying it's taking over the planet. I'm not saying that the whole world is going to be InfiniBand tomorrow. I'm saying that as an infrastructure network, it's extremely valuable. Oracle uses it for a lot of inter-system communications. Some other vendors use it for intercontroller communications. It's extremely low bandwidth and high latency. It's not the only way to skin the cat. What I'm saying is that I think InfiniBand is a good, solid technology, and it will grow. The two-socket server goes along with our scale-out discussion that we already have. I think I explained that, at least my view on it. And capacity disk is going to grow. And that's contrary to what I think everybody in the industry seems to be saying. I feel like we're on a bandwagon right at the moment where talking about HDD is like talking about gluten. Everyone wants to be gluten-free. But I don't think it's a good comparison, and I think HDD is valuable, and that cost differential tells you why. Flash is growing. It's the most rapidly growing thing in the industry. It's an inflection point. It's extremely important for all of us, as well as a hell of a lot of fun, because it's a big change, and it's a technology that we can leverage. But look at performance disk. Performance disk is kind of neither fish nor fowl. The problem with it is it's only 8x cheaper than flash by one estimate. I don't think it matters if the number is 5x or 9x. But it's squeezed between capacity disk, or what some people call nearline, and flash. It doesn't have anywhere near the access performance as flash, and so I would say that it's going away. Dedupe technologies, or compression, or pick your favorite, but these technologies, where do they fit in this equation for storage arrays? Well, unfortunately, Oracle doesn't see them very valuable in the case of database. Okay? The reason is because dedupe has a negative impact on performance. It just does, and that's factual. It doesn't reduce data very well because each 8K header, even if you go to a sliding 8K window instead of 4K, each HK header is unique. And when people start using dedupe for databases, they're talking about multiple databases to try to get the effect that you see in VDI, okay, of dedupe. I'm not saying dedupe is useless or not a good technology. It's useful and it is a good technology, but not for every application. Sometimes there's a better solution. If you encrypt the data at rest as it's sitting out on the storage system, dedupe is not very useful for that in that instance either. What Oracle does is a technique called hybrid columnar compression. Hybrid columnar compression can be done in gradients of compression ratios. So you can go from lightly compressed and easy to hydrate all the way to extreme compression, which is much more difficult and CPU intensive to hydrate. And we use this in conjunction and let the Oracle database software through ASM manage the storage and manage the compression. The higher up you go in the chain and can manage caching and the effects of compression, the better you are. Would you rather be a storage system guessing what Oracle's doing with the data, or would you rather be the application like database that knows what it's doing? I think that the answer is clear, and that's why we've picked this technological direction. This is not a commercial. I realize most of the people in here aren't buying storage arrays, but I wanted to outline what we built, what we're shipping, so you can see that it fits in the direction of what I just outlined. We built a product, and the press release will go on it this week, but it's been shipping for over a month, called the All-Flash FS1. It has there's another product in our flash storage lineup called the FS1-2. That was announced by Larry Ellison at Oracle Open World and was shipping since October or November of last year. So these are our two flash storage systems. I told you I'd mention an ancillary thing that we do with flash. This is one of my favorite things. It's not that popular yet, but I think it will gain in popularity. This is fun because it gives us the speed of writing it at RAM speed because it's on the memory bus. It's just a non-volatile DIMM, and we use flash on the back of that DIMM to provide the backup in the event of catastrophe of any kind, except perhaps maybe a bomb blowing up the system. But in the event of a power loss or that sort of thing, that's what this function does, and it's fantastic for our write cache. So big picture landscape, lots of nodes, scale-out architecture, petabytes of flash, millions of IOPS, lots of throughput. And then we have another feature that we use, that we've developed. We call them storage domains, and it's essentially one step back from perfectly virtualized, where you're able to segregate storage containers and physical assets and identify where that storage is in the system. And then, of course, a full suite of data services, because this is actually our 6th generation of code, having used the code from the Pillar Axiom as one of the base starting points for this design. The All-Flash Cloud, then, is a reality, certainly at Oracle. Block I/O services with flash performance, provisioning of IOPS on flash, no disk in the case of the All-Flash FS1, and scale up and scale out non-disruptively. It's important to say that the control plane of this system, the all-flash FS1 has to be very fast. And it is, in part due to the flash, meaning that you can create, delete, map, unmap, and clone LUNs very quickly. Because to be effective, the system has to have 1,000 or 3,000 users on it, not 9. And that means that there's a dynamic load on the system, but which you stand up users using the storage and you tear them down and move them somewhere else, or they're just gone. That's the cloud. So that aspect of this product and the all-flash FS1 is critical. The future, I'm wrapping up here. This was an accidental background. It might remind people of Crosspoint a bit, but it was an accident. It really was, actually. The cloud is going to drive an avalanche of adoption of flash. And the speed of adoption, this is for the array business. The speed of that adoption is going to be moderated by availability and price pressure. The world is not going to take 90% of its shipped petabytes and turn it to flash next year, unless somebody has a miracle ability to build a lot of fabs really quick. Low latency with minimal fall off is going to become a cornerstone of the cloud. Exploitation of flash for storage systems would be better achieved if we could come up with a higher RAS packaging volumetric solution. We need to get rid of the HDD form factor, and I'm not sure for arrays that the PCIe bus and the hot pluggability and the slide out the drawer and lift the lid is really the solution. It's not unworkable. It exists today, but it's not my favorite. So if I had an ask from the industry, I would like us to cooperate on a better form factor for flash like we did for HDD and we do for SSDs. Clearly, NVMe, by the way, is better for latency, and we all love that. That's a nice feature, but it has its other issues, as I've mentioned. And I think flash is really going to force the migration towards scale-out architectures. You see that in the way some of the bigger storage array companies today are taking R&D dollars away from the old traditional approach and moving towards scale-out architectures, and you see the growth in their businesses, and certainly the growth in Oracle's are in the flash arena with scale-out architectures as the ones I've described. And the price differential, I predict 5 years. Everybody's willing to, or is welcome to make their own prognosis. Making a prognosis is dangerous. When I worked at IBM in 1982, a very high-placed executive stood up and said, tape would be dead in 5 years. So I should have learned and left this lower bullet off. Making prognosis about how long a technology is going to live is probably a dangerous business. But nonetheless, I would say this, without any danger, HDDs will not be gone next year. Stunning. In life, at least I believe, and I suppose it might even be cliche, but I think balance is required. Flash is here. It's an inflection point, and if you're a customer and you're not looking at flash, if you're a customer of storage arrays and you're not looking at flash, you're missing it. If you're a vendor and you're not working on flash, and this may, looking at this room today, may mitigate my worry about that, but if you're a vendor and you're not looking at flash, you're missing it. We're at an inflection point in the industry. There's been very few of them in my career. They've all been fun, so what I would say is have fun with this inflection point. Thank you very much for your time and attention.
Thank you very much.
Thank you. Thank you.